So for 7.4, we have integration of rational functions by partial fraction. This is called partial fraction decomposition. What I have showing right here are some of the tools you're going to need for 7.4. Some of these basic integrals. You're going to see a lot of integrals that once you do the arithmetic, once you do the partial fraction decomposition, that you're going to have some integrals like this. A lot of them are going to be natural log integrals. Not all of them, but a lot of them. And so I threw in this fourth one down, the integral of 1 over x plus 5, that quantity squared. That one is not a natural log integral. And so I showed the step there. That's the regular use substitution. This last one, be alert. You might see the one that the antiderivative is going to be inverse tangent, which is the same as arctangent. On the next page, I went through this little tool where I said, okay, remember how when you were adding fractions, you had to get a common denominator, that you need to remember how to get common denominators. And of course, I did it here with just numbers, but also when you were in algebra class, they did some of these where you had these rational expressions. So our job is going to be, you're going to find an integral, something like this, maybe some written a little differently. This right here is a basic problem from 7.4. Something like this. Your job is going to be to take the fraction, write it as the sum of two fractions. Once you have it as the sum of two fractions, you do the antiderivative. The calculus part of this is fairly straightforward. It's kind of simple, the calculus part. So we got to talk about this little algebra part right now. So I'm going to show it for this problem, and I will show it for some other types of problems, because they have some different types they're going to kind of throw at you, and you just kind of need to know what to do with what type. So I'm going to pretend I didn't work this problem yet. I'm going to start this one from the beginning. So I'll call this example. I want to find the integral of 5x plus 7 over x minus 1 times x plus 3, and that's dx. So I'm seeing the rational expression, and I'm thinking it looks like a partial fraction decomposition problem to me. So I have to take the 5x plus 7 over x minus 1 times x plus 3, and I am going to try to split this into two fractions where one of them has x minus 1 in the denominator. I'm going to write a over x minus 1, and the other one has b, well, in the numerator, not the denominator, but a in the numerator, x minus 1 denominator, plus b over x plus 3. And I do need to mention this. These denominators, x minus 1 and x plus 3, they are linear expressions. What does linear mean? Raised to the first power. The x is raised to the first power. So if this breaks down into linear factors, where the x is to the first power, then in the top you have a single number. And we just use capital A to represent that number. And then x plus 3 is a linear factor. So in the numerator for that, you're just going to have a b, a single number. We'll just let b hold the place of that single number. There are a couple of ways to work these problems. And you kind of have to look at the problem and weigh your options and go with what you think might be the easiest. Now, what I'm going to do on this first problem is probably not the most efficient way, but it's going to follow what I did yesterday with this problem. It'll follow this, something that you kind of know already, and it's kind of look like this. So, while I'm saying I want to split this into two fractions, what I'm actually going to do is I'm going to take these two fractions and I'm going to add them together. So, I'm looking at it and I'm thinking the common denominator is x minus 1 times x plus 3. So, for the first fraction, a over x minus 1, I have to multiply the top by x plus 3 and multiply the bottom by x plus 3. And then what do I have to do for the second one? Multiply by x minus 1 in the top and the bottom. And there's no reason for you to start multiplying the denominators. And again, that's sort of something from practice. How do you know you're multiplying the numerators and not the denominator? And that's where the practice comes in. I'm going to distribute the a and get ax plus 3a, and distribute the b plus bx minus b over x minus 1 times x plus 3. In that numerator, I will group the like terms. So ax plus bx is a like term, and then plus 3a minus b. The ones that have the x's and the ones that have just the, I want to say letters, but the constants. 3a is a constant, b is a constant right there. Where I have that ax plus bx, I will factor out an x. So I'm going to put it at the back. A plus b times x, a plus b is in parentheses, plus 3a minus b over x minus 1 times x plus 3. That's what I have. I'll give you a minute to catch up if you're writing some of that. Now that I have added the two fractions together, I kind of want to make a note. Okay, that equals 5x plus 7 over x minus 1 times x plus 3. Now this next step, this is where I can go through the whole thing, and there'll be some students who raise their hand and they say, I don't know how you got that next step. So I'm going to kind of challenge you with this. I'm going to write the next step, and you look at it and see if you can tell me how I know this. So a plus b equals 5, and 3a minus b equals 7. So what I did is I formed a system of equations that now I can solve for a and b. Raise your hand if you know where that came from. Okay. Where did it come from? This top part. Look, I have x minus 1, x minus 1, x plus 3, x plus 3. That all matches. I have the x and it matches this x. So a plus b better match the 5. And 3a minus b better match that 7. So I formed this system of equations, and then from here I can solve this system of equations, which they probably covered maybe in advanced math in high school, or maybe algebra 2. If you took algebra here at LSU, it's probably one of the last topics they cover for the semester. I'm looking at this and I'm seeing I have a positive b and a negative b. I can add these equations together and eliminate the b's. it'll give me 4a equals 12. And then divide both sides by 4, and a equals 3. How do I find b? Plug it back in, and I'm going to go with the top one. A plus b equals 5. If a is 3, 3 plus b equals 5, so b equals 2. So what I found now is exactly what I was looking for here. I know that a is 3, b is 2. So my calculus problem is now, I'll just rewrite the whole thing right here. The integral of 5x plus 7 over x minus 1 times x plus 3 dx, that equals 3 over x minus 1 plus 2 over x plus 3. Those two fractions, the dx. And now that's an easy integration problem. So a lot of the problems in 7.4, once you break it down, not all of them will be easy, but a lot of them, see, here it is now. This is two separate integrals. I'm going to factor the 3 out. So it's the integral, 3 times the integral of 1 over x minus 1 dx plus 2 times the integral of 1 over x plus 3 dx. And the antiderivative of 1 over x plus 1 is the natural log. You need absolute value of x minus 1 plus 2 times the natural log of the absolute value of x plus 3 plus c.